kilonewton per meter square. Assume gamma is 17 kilonewton per meter square. Now see here, this is a simple case of square footing where the soil is a pure clay, right? So this is the simple case. What is given in this case? This is the square footing. The square footing is resting on a saturated clay, or it is a pure clay. If it is a pure clay, means naturally the value of phi is equal to 0. Value of phi is equal to 0. Value of phi is equal to 0. And if this is the square footing of size 1.5 by 1.5 meter, and here the depth is also given as 1.5 meter, right? So this is also 1.5 meter. The footing is a square footing. If it is a square footing, the size, both the sides are 1.5, and here is 1.5, right? So first, nothing is mentioned about whether the soil is a sandy local shear failure or the general shear failure is expected, because here if the soil is a pure clay soil, in that case by default phi is taken as 0, and if phi is 0, in that case NC have to taken as 5.7, N2 is 1, and N gamma is 0. So here first the footing is a square footing. Footing is square footing. If the footing is square footing, what is the equation? The equation of QU is equal to 1.3 CLC plus QNQ plus 0.4 T into gamma into NH. So this is the equation for square footing. Naturally, if the phi is 0, means the soil condition is, or soil phi is less than 28 degree, means it is comes under the local shear failure, but that is not taken into consideration directly when soil is clay. This is basically the guidelines that you should know. कि ये आपको कभी नहीं बोलना है कि मैडम इसका फाई नहीं दिया है, इसका एनसीएन क्यू एन गामा नहीं दिया है, nothing. You have to, whether it is mentioned the soil is a pure clay, in that case the soil is clay, means phi value is 0, and if phi value is 0, the value of NC is 5.7, NQ is 1, and N gamma is 0. This is by default. Always remember, when there is a pure clay, phi is equal to 0, NC is by default 5.7, NQ is 1, and N gamma is 0. Now if N gamma is 0, naturally this term will be 0. In the equation, the third term will be 0, and therefore this QU is equal to 1.2. Now what is given? Q is given as, instead of C, the value of QU, that is ultimate bearing capacity, unconfined compressive strength is given, and this Q is 150 kilonewton. So if C is 150 by 2, if unconfined compression strength is given, so it will be 75. So here this 1.3 into 75 into 5.7 plus gamma is given as 70 into DF is 1.5 into 1. So directly you have to find out the value of LP, right? You have to find out the value of Q ultimate, right? So what is the answer? It is 581. It is 581 kilonewton. What will be the unit? The unit, always remember that when the problem is becomes three-dimensional, isolated footing is there. In that case, if there is a definite area, and therefore the pressure or the bearing capacity is in kilonewton per meter square. Right? Write down the next problem. Next, what is the ultimate bearing capacity? What is the ultimate bearing capacity of a circular footing? What is the ultimate bearing capacity of a circular footing of 1 meter diameter, 1 meter diameter, resting on a sand, resting on a sand of phi is 36 degree, of phi is 36 degree, phi is 36 degree, and gamma is phi is 36 degree and gamma is 17 kilonewton per meter cube. Gamma is 17 kilonewton per meter cube. Determine the net ultimate bearing capacity. Determine the net ultimate bearing capacity for the foundation. For the foundation. Now, just write down the values for Terzaghi's bearing capacity value. The value is given for the 35 and 40, right? So you have to calculate it for the 36. So write down for 35. For 35, NC is given as 57.8. So this is phi, NC, NQ, and NM. Phi is given for 35 degree. Now, here the value, which type of foundation is given? The foundation is given as a circular foundation. So, the problem is entirely different in this case. In the previous one, there was a pure clay. If pure clay is there, phi value is taken as 0. But here, this is a circular footing of diameter is given as the diameter of the circular footing is given as 1 meter. And again, here is 1.2 and here it is 1 meter. Gamma is given as 17 kilonewton per meter cube. See? So this is a pure sand. So sand is given. In this case, the footing is a circular footing. Footing is circular footing. As it is a circular footing, the equation of circular footing is QU CLC plus QNQ plus 0.3 E into gamma into N. Now here, always remember that the circular footing is never suggested to use over the field. In practice, the circular footing is never suggested, because always remember that circular footing is having bearing capacity always less than the square and rectangular footing, as the multiplication factor for the third is directly reducing by 0.1. Right? So in this case, this is the equation. Now, if the soil is pure sand, soil is pure sand, means here the value of C is 0. The value of C is 0, and therefore this first term will be 0. So in such cases, the value of Q ultimate is equal to what is gamma? It is 17 multiplied by 1.2. Then you have to interpolate the values because there is two values for 35 and 40 is given. So you have to interpolate between values and calculate these values. Once you get this calculations by the interpolation, then you have to just write down the things. And here it will be 0.3 into B. Instead of B, now here it will be D. And D is 1 meter into gamma is 70. And LQ again you have to find. Right? What is the answer? Just calculate it. It is 1283.97, right? 1283.97. That's kilonewton per meter square. I think here you have to find out the ultimate bearing capacity, the net bearing capacity. So Q net is equal to 1283.97 minus 1 into 70. So you have to find out the ultimate bearing capacity and then you have to find out the net ultimate bearing capacity, right? Right. The next numerical. Third. A foundation 2 meter square. A foundation 2 meter square is installed 1.2 meter below the surface of 1.2 meter below the surface of uniform sandy gravel having density 19.2 kilonewton per meter cube, 19.2 kilonewton per meter cube, comma 19.2 kilonewton per meter cube above the water table, and a submerged density of 10.1 kilonewton per meter cube, submerged density of 10.1 kilonewton per meter cube, full stop. The strength parameter with respect to effective stress R phi dash is equal to 30 degree. Phi dash is equal to 30 degree. Find the ultimate bearing capacity. Find the ultimate bearing capacity for the following condition. First, water table is well below the base of the foundation. Water table is below the base of the foundation. Then second, water table rises, water table rises to the level of the base foundation, and third, water table rises to ground level. Water table rises to ground level. Now see here, the problem is with the and in this case as phi is 30 degree, but directly the effective parameters are given, means no need to take into consideration the local shear failure. Directly phi dash is given, means that is the after considering the local shear failure, phi is given, right? So phi effective, write down, for phi dash is equal to 30 degree, for phi dash is equal to 30 degree, NQ dash is 22, NQ dash is 22, and N gamma is 20. N gamma is 20. Now, this is the case when the local shear failure is expected, but nothing to consider whether C and C phi, nothing has to consider. Directly the effective parameters are given, right? So, what is which type of footing is there? The footing is a square footing of size 2 meter by 2 meter, and which is resting over the 1.2 meter depth, right? So, in this case, this is a square footing of B is equal to 2 meter, right? And here the B is given as 1.2. B is given as 1.2. Where it is resting over the sand. If it is resting over the sand, naturally C value we have to take at 0. Now, in this case, the three conditions are given. In the first condition, the water table is at a large depth. Yes, if the water table is at a large depth from the base of the footing, need not to take into consideration the effect of the water table. Means no effect of water table. No effect of water table on bearing capacity. Right? So here the second term is given. In this case, the water table is at this distance. Which term is getting affected due to this? The submerged soil is this. So what is this term? This term is foundation soil. So which term of the equation is getting affected? The third term of the equation is getting affected. As in the second case, the third term of the equation is getting affected. And in the third one, the water table reaches to the ground level. And here, this is the third case. Now here, which term of the soil is getting affected? Both the foundation soil and surcharge soil. Both second and third term is affected. Is it clear to all? Is there any doubt? Is there any doubt in this? Which term and how it is getting affected? Is there any doubt in this? Yes, anybody? Astha? Astha? Abhijit? Do you have any doubt? Please text me. Or it is clear. Should I proceed? अभी डाउट नहीं है कोई? आगे जाऊं मैं? अद्वैत?
No, ma'am, कोई doubt.
In this now, this is the three cases which are given. One thing you always remember that अभी आपको इसमें इसके पहले वाली कोई प्रॉब्लम में आपको submerged density was not given, but here the submerged density is given, and many times in some of the books we are not taking into consideration the reduction factor. Reduction factor को आपको consideration में नहीं लिया है और submerged density given है. तो यहाँ पर एक तो आपको सबमर्ज डेंसिटी कंसीडर करना है या फिर रिडक्शन फैक्टर लगाना है, दोनों में से एक ही चीज करना है। और सबमर्ज डेंसिटी सिर्फ ऐसे केसेस में हम कंसीडर कर सकते हैं कि जहाँ की सॉइल पूरा के पूरा कंप्लीटली सबमर्ज कंडीशन में, जहाँ पे अभी थर्ड केस में, सेकंड केस में यहाँ पर जो है ये थर्ड टर्म के लिए हम गामा सबमर्ज कर सकते हैं। जब हम सेकंड केस के लिए इक्वेशन सॉल्व करेंगे तो we can take the gamma submerge for the third term instead of taking 0.1, right? और तीसरी यहाँ पर अगर आते हो तो you have to take both this gamma submerge, and if you are taking gamma submerge, in that case you need not to consider the RW1 and RW2. दोनों अगर फैक्टर्स आप लगाते हो तो आपका रिडक्शन जो है वो डबल हो जाएगा, ठीक है। तो ये लेकिन कब कर सकते हो आप, जब एक्सट्रीम केसेस में at the base the complete soil below the foundation is submerged, यहाँ पर है तो ये भी submerged और ये भी submerged, is it clear? दोनों में से एक ही चीज करना है। यहाँ पर हम गामा सबमर्ज लेकर सॉल्व करते हैं तो एक आध बार ऐसा भी कुछ आ जाता है, तो यू शुड बी क्लियर, the idea should be clear, is it clear? So first case 1, which is case 1? Case 1 is water table is at grade depth. Water table is at grade depth. Again, the soil is given as a sandy soil. Soil is given as a sandy soil. So naturally, if the soil is a sand, in that case, C is taken as 0. What is the footing? Square footing. Square footing. Directly, if the C is 0, we will just write down the equation directly. That is QU is equal to gamma into dF NQ plus 0.4 D into gamma into N. So this is the equation, because the first term as C is equal to 0, therefore the first term we will not take into consideration and directly come to the equation, that is gamma into df into 0.4 d into gamma into n. Just calculate it. So it is found to be 814 kilonewton per meter square. It is found to be 814 kilonewton per meter square. Is it? Right? So, case 2 now. If suppose in the case 2, water table is at the base of the footing. After footing. So when it is at the base of the footing, the foundation soil is in a submerged condition, and therefore foundation soil is in submerged condition. Submerged soil is the third term where the soil is in a completely submerged condition. So here, what we will do, instead of multiplying the third term by the reduction factor, we will just take into consideration the gamma submerged. ठीक है, दोनों में से एक ही चीज देना है। कभी कभी आपको न्यूमेरिकल में gamma submerged दिया है तो don't consider the RW, because but वो कब कंडीशन में यूज कर सकते हैं, जब एक्सट्रीम कंडीशन में एकदम बेस में है कि पूरा का पूरा सॉइल सबमर्ज हो चुका है, यहाँ पर एकदम ग्राउंड लेवल पे है तो ये पूरा का पूरा सॉइल सबमर्ज है। अगर यहाँ पर इन बिटवीन कहीं पर आता है तो then you have to consider the reduction factor only, right? So in this case, QU अभी कौन सा टर्म अफेक्ट होगा, थर्ड टर्म अफेक्ट होगा। सेकेंड टर्म में अभी तक ये पानी नहीं आया है, सरचार्ज टर्म में अभी तक ये वाटर की एंट्री नहीं हुई है, तो यहाँ पर हम वही सरचार्ज कंसीडर करेंगे। सो ही डेंसिटी कंसीडर करेंगे। सो हियर इट विल बी गामा इनटू df इनटू nu प्लस 0.4 into B into gamma submerged. Now here we are taking this gamma submerged. If you are not taking gamma submerged, in that case you consider the RW1 with the same density value. Anything? Is it okay? Move to camera on left hand side. Is it okay, Rohan? So this is the case 668.48. This is 66. This is 668. This is 668.48 kilonewton per meter. Right? Now we will consider the third case. Here the water table is at the ground level. So in this case 3, water table is at ground level, where foundation soil and surcharge soil are in submerged condition. So both the soils are in submerged condition, and just write down the note over there. This is the critical worst condition of the bearing capacity. क्या लिखना है? This is the critical worst condition of bearing capacity, where the SBC of soil, is minimum. SBC of soil is minimum, and losses around 50% its strength. 50% of its strength, right? अभी तक के ये यहाँ पर जो है हमने अल्टीमेट बेयरिंग कैपेसिटी वाले कैलकुलेशंस किए हैं, बट मेनी टाइम्स द न्यूमेरिकल मे बी you have to just determine the size of the footing if the loading is given, and you know the parameters, different parameters. In that case you can find out the loading, the size of the footing. Write down. A circular footing is resting on a steep saturated clay. Circular footing is resting on a steep saturated clay with QU. Steep saturated clay with QU is 250. QU is 250 kilonewton per meter square. Kilonewton per meter square. The depth of the foundation is 2 meter. The depth of the foundation is 2 meter. Full stop. Determine the diameter of the footing. Determine the diameter of the footing. If the column carries a load of column carries a load of 600 kilonewton. 600 kilonewton. Full stop. Assume a factor of safety of 2.5. Assume a factor of safety of 2.5 and the bulk unit weight of 20. And the bulk unit weight of 20. Now here, the footing is given as a circular footing and it is resting over the plate. If it is resting over the plate, means phi is equal to 0, and if phi is equal to 0, the NC becomes 5.7, NQ is 1 and N gamma is 0. Right? So in this case, you have to find out the diameter of the circular footing. Now, this is the circular footing. The circular footing having the diameter is d, whereas the depth is given as df is given as, I think it is given as 2 meters. 2 meters. This column is subjected to load of 600 kilonewton. And in this case, load आने वाला जो है that is fixed, and in that case you have to find out the diameter of a circular. Here, the soil is considered as clay, means the value of phi is equal to 0. Therefore, NC is equal to 5.7 and NQ is equal to 1. Whereas N gamma is taken as 0. As N gamma is 0, so naturally the third term of the equation is 0. And here, then, what is Q? It is 1.3 CLC plus Q plus 0.3 D into gamma into N gamma. So this is the equation. Again, this term is 0. Right? So in that case, we will just calculate Q is equal to 1.3 CLC plus QQ. Find out the value of Q ultimate. Then find out Q safe, and Q safe is equal to QQ minus gamma into DF upon factor of safety plus gamma into DF. Once you get this, Q safe, then in that case, safe load is equal to Q safe. This is safe load or arrival load. Is equal to Q safe multiplied by A. Multiplied by area of the footing. Now here this safe load is given, and this safe load is given as 600 kilonewton, and this is found to be whatever is the value, and then what will be the area of the circular footing? It is pi by 4 d square, and you just find out the d. It is D is found to be 1.365 meter. Is it clear? It is bulk unit weight. Is there any problem with the unit weight? It is not given. Yes, gamma is given as 18 kilonewton per meter cube. 18 kilonewton per meter cube is the density. रोहन, लक्ष्य, अरुंधति, अभी इसके और न्यूमेरिकल्स हमें लेने हैं कि कुछ न्यूमेरिकल्स मैं आपको होमवर्क दे दूं एंड शैल वी स्टार्ट द नेक्स्ट टॉपिक इन द नेक्स्ट क्लास? जस्ट टेल मी whether you want some another numericals on this topic or shall we proceed? होमवर्क दे देती हूँ मैं आपको 5-6 प्रॉब्लम्स होमवर्क दे देती हूँ अलग अलग टाइप्स के,